Hello students, in this video I am going to talk about the implementation of a boolean function using 74153, that is multiplexer IC. Let us start. 74153 IC is a 4:1 multiplexer. So now let us first of all have a quick revision. What is a 4x1 multiplexer? A 4x1 multiplexer is going to have total 4 input signals, C0, C1, C2 and C3, and we are supposed to have 2 select lines A, B, and only one output signal is going to be there, which is Y. That is 4x1 multiplexer. Now about the operation. In 4x1 multiplexer, when the select lines are 0, 0, output is C0. When the select lines are 0, 1, C1 is output. Select lines 1, 0, C2 is output, and select lines 1, 1, C3 is output. So this is your 4x1 multiplexer. Now the pin diagram. 74153 IC is having total 16 pins. Starting from this notch, below notch, we always start with pin number 1. So 1, 2, 3, 4, 5, 6, 7, 8. Then we have anti-clockwise direction 9 till 16. So this is how our all the pin numbers are going to work. Pin number 1 is known as strobe pin. Basically this is strobe bar. If a bar is mentioned on any pin, that signifies that the pin is active low pin. What is active low pin? When a low signal is given, the pin will become active. Hence, pin number 1, which is actually enable or strobe pin, must be connected with ground. 74153 IC is used for the implementation of total 2 4x1 multiplexer. So initially, let me show it to you as well. As you can see, 1 is written on multiple different pins. So 1 means the first multiplexer. So we have 4 input signals for the first multiplexer, 1 output signal for the first multiplexer, and A and B are our select lines. Similarly, the second multiplexer is written as 2, numeric 2. So 2 means the second multiplexer. As I have told you that we are supposed to have 2 4x1 multiplexers available in 74153 IC. So C0, C1, C2, C3, these are 4 input signals, Y is output. Similarly, C0, C1, C2, C3, 4 input signals, Y output. But the select lines are going to be common for both the multiplexers. That means the same select lines A, B, pin number 2 and pin number 14 will be used for first multiplexer as well as second multiplexer. Pin number 8 ground, pin number 16 VCC. Now strobe 1 bar is for first multiplexer, strobe 2 bar is for second multiplexer. So bar means active low pin, so it must be connected with ground. Hence, if you want to use first multiplexer, pin number 1 must be connected with ground, and if you want to use second multiplexer, then pin number 15 must be connected with ground. Next is the testing of IC. How we can test the given IC, starting with the enable pin, that is strobe. As already discussed, that the strobe pin is active low pin. That means it must be connected with low signal, 0 signal, then only it will start working. So over here in this truth table, H stands for high voltage, that means 1, L stands for low voltage, that is 0, and X is don't care term, that means it can have any value, it will not have any effect on our output signal. Let us discuss. When the enable pin is high, so our multiplexer has not been enabled yet, so at that time doesn't matter what is the value of select lines, input signals, the output is always going to be a low signal, that is 0. Now when we have started providing the enable signal to be equal to 0, because active low pin, so 0 means our multiplexer will start working now, then only our multiplexer will give us the outputs. Starting with the first case, when the select lines are 0, 0. So when the select lines are 0, 0, output is C0. So if C0 is low, output is low. If C0 is high, output is high. Doesn't matter what is the value of the remaining input signals, the output will not change. Second case, 0, 1. So when the select lines are 0, 1, output is C1. So if C1 is 0, output is 0. C1 is 1, output is 1. Third case, when the select lines are 1, 0. For 1, 0, output is C2. You can have a look over here. When C2 is low, output is low. When C2 is high, output is high. and the last case is 1 1, that is high signal. For that, C3 is going to be the output. So in this manner you can also test the multiplexer IC on the digital trainer kit whether your multiplexer IC is working perfectly fine or not. Now here I have taken one example. I have considered this question that implement the given boolean expression using 74153 multiplexer IC, and I have taken 1, 2, 6 and 7. But you can implement any random question as well based on SOP, POS, maybe any other boolean expression as well with the help of same format which I am going to follow right now. So here comes our question 1, 2, 6 and 7. So the first task is going to be write down the truth table. So for the truth table, as we have total 3 select lines over here, A, B, C, 3 select lines. So total 8 combinations are available over here. 1, 2, 6 and 7. So here comes 1, 2, 6 and 7. So 0, 0, 1, 1, 0, 1, 0, 2, 1, 1, 0, 6 and 1, 1, 1, 7. So all these entries I have filled with the value 1 because the portion belongs to SOP. On the other hand, the remaining values are filled with 0. So this is how you can write down any random given portion into the truth table. Once we have received the truth table, now it will become very easy to simplify using multiplexer IC. Now in multiplexer IC, we are only having 2 select lines which will be mapped with 2 variables here, A and B. So now how you will be able to continue with the remaining value, because for the given boolean expression we have to make the connections of all the 3 variables as per the given question, that is A, B, C. Although A and B will be connected directly with the 2 select lines. Let us start. When select lines are 0, 0, output is C0, 0, 1, C1, 1, 0, C2 and 1, 1, C3. Now let us calculate the value of C0, C1, C2, C3 as per the given question. So when C is 0, Y is 0, C is 1, Y is 1. That means Y is exactly replica of C. Hence, C0 is equal to C. Second case, C0, Y1, and when C is 1, Y is 0. So that means Y is getting a complement output. Complement output means C1 is equal to C bar. Third case, C0, Y0, C1, still Y0. That means Y is 0 for both the cases. Doesn't matter what is the value of C, it will remain to be equal to 0. 0 means low voltage level, that is ground. Similarly, C0, Y1 and C1 still Y1. That means Y is 1 for both the cases, doesn't matter what is the value of C. So 1 means high voltage level, that is VCC. So now here we have calculated the value C0, C1, C2, C3 as per the given boolean function. Now the connections. As already discussed, pin number 1 is going to be connected with ground. Pin number 2 and pin number 14 will be connected with A and B, because right now we are going to have 3 input signals as per the given boolean function. Now C0, the value that we have calculated for C0 is C. So hence C will be directly connected with C0. The value for C1, it was C bar. So how to calculate C bar? For the given boolean expression we require 7404 IC as well, that is the IC number of NOT gate, because we want C bar as well. So let us drag pin number 6 to pin number 1. That means we have given C signal to pin number 1 of NOT gate. Pin number 2 now will become C bar, hence pin number 2 will be connected with pin number 5 of 74153. That means we have given C1 to be equal to C bar. After that, C2 ground, C3 VCC, pin number 8 ground, pin number 16 VCC and pin number 7 output. Also do not forget to connect ground and VCC at pin number 7 and 14 respectively to 7404 IC, that is NOT gate. So this is all about your connections. Now let us see how these connections are going to work on our apparatus as well.